1, we're given a line passing through 2 points. We want to find out a bunch of things about that line. So we'll start with this vector equation. For lines, don't forget we need to have directions. We don't need points, we want directions. So first thing we should do is figure out the direction from A to B. So we use our vector subtraction IB. And you could also do BA if you so choose, nothing wrong with doing that. So we got 7, 1, and 1. So our vector equation would be R equals a point, you pick, A or B, your choice, -3, 2, 8, plus our parameter, 7, 1, 1. There's your vector equation. Parametric, we just pick the x part, so the -3 and the 7t. Y would be the y part, so 2 plus t, and z would be the z part, 8 plus t. Turn that into a symmetric equation. So x plus 3 over 7, y minus 2 over 1. You don't have to show the 1 if you don't want to. And z minus 8 over 1. And in part B, we want to figure out if this point lies on the line. The easiest way to test that is by using your symmetric equation. If you fill in your x, your y, and your z in the right spots, then your 3 symmetric equations should come out to the same value. So let's try it. So -5 plus 3 over 7 should equal 2 minus 2 over 1, and that should equal -3 minus 8 over 1. Well, the first one is -2/7. The second one is 0. Don't even really need to test the last one. Let's do it. And what do we notice? These are definitely not equal to each other, so this point is not on the line. They're not equal to each other. In part C, determine the symmetric equation of a line parallel to the original line. So, our choice and how we want to go about doing this. If it's got to be symmetric, we can pick any point we want to, but the parts on the bottom have to be the same. So the simplest one would just be saying that. That would be symmetric. But you could choose any points you want to here, add a point in or not, and those things would be symmetric. In part D, determine the coordinates of another point on the line, assuming it's back to the original line. So if we want to find a point on that line, we can pick any parameter we want. Let's see what happens when t is 2. We'll plug that back into our, oops, how do we do that? We'll plug that back into our parametric version, and we'll end up with x equals -3 minus 7 times 2, which is -17. We'd end up with y equals 2 plus 2, which is 4. And we'd end up with z equals 8 plus 2, which is 10. So a point that's on this line, -17, 4, and 10.